everyone, I just wanted to make a quick video just to show you an example on how I would use MOS or model output statistics in order to forecast the weather or just to create a very basic 2-day forecast. And I know in the MOS video that was in the lecture material, it can seem a little bit overwhelming, especially since it's all basically in code and it's in sort of a grid-like format. And it can be a little bit complex the first time around when you're first seeing it. I remember when I was in school seeing it for the first time and being told to use it to create a forecast was quite overwhelming. I looked at it like it was, something from out of this world. So I just wanted to make another video just to break down how I would use MOS. So just to click on the website that I provided for you, it comes up with this page. And under the select station, I'm going to actually forecast for my old hometown of New Bedford, Massachusetts. So the station code is EWB. I'm going to click on, or I'm going to select model data, and then I'm going to click on all guidance forecast, and then hit data, and then you can see both the NAM MOS guidance and the GFS MOS guidance. And you'll notice that these are going to be decently similar to one another, but there'll be some slight differences, and that's just how the weather world works. Each model is built a little bit differently, and therefore it's going to spit out a different outcome, or it's going to have a different idea on what the forecast may look like. And that's one of the reasons why weather forecasting is not always straightforward. But in any case, I'm just going to break this down for you. So I'm going to make a forecast for Thursday and Friday, which would be September 10th and September 11th. So I want to find out the highs and the lows first. That's usually one of the main parameters that people want to know. What's the temperature going to be tomorrow? And so this is a great way just to figure it out rather quickly. And so here, the NAM MOS, it's saying for tomorrow, it's saying 79 degrees. Now, just to go over what these different columns mean really quickly, at the very top, we have DT, which would be the date. So here's the rest of September 9th. Here is going into September 10th. All this is September 10th. And then look what happens as soon as we get to 0Z, right, under the hours. As soon as we get to 0Z, it starts the new day. Remember, if you refer back to the How Do You Read Zulu Time video, Z time is important simply because we all have to be on the same page. So even though it's not midnight here on the East Coast, it's midnight in Greenwich. And so they technically see the new day before anybody else. So based off of Z time, 0Z would be midnight in Greenwich, or because where we are on the East Coast, our local time is 8 p.m. So this would be the high indicated, this N/X line would be the low of the day and then the high of the day. The low of the day occurs right around sunrise. We'll talk a little bit we'll talk more about why that is later. And then once you get to 0Z, this would be the high for the day. So here for September 10th, the NAM MOS says, hey, I'm predicting a low of 67 degrees by 12Z, which would be 8 a.m. on the East Coast. So 67 degrees for a low and 79 for a high. Okay, well, the GFS MOS says, I think the low is going to be 68 and the high is going to be 77. So these are pretty much similar. They're very not far off from one another. In the real world, you can kind of just interpolate between the two, either a low of 67 or a low of 68. And because I know my hometown and because I know where New Bedford is geographically, it tends to run a little bit warmer. So I think for my low, I'm going to go for 68 degrees. And then for my high, what I'm going to do is I see the NAM says 79. The GFS says 77, so I'm just going to split the difference between the two, and I'm going to take an average. So I'll say 78. So I just set mine up like this just so you can see. You don't have to set yours up this way, but I just did. So the high is going to be 78, and the low is going to be 68. That's what I'm going to go with. Okay, cool. So now when it comes time for winds, okay, so wind direction, WDR. So you're going to want to add a 0 to the end of all these numbers. So see here we have 17, and then we have 18 and 18 and 16 and so on and so forth. Well, you're going to want to add a 0 to that. And that means that the direction the wind is coming from is at 170 degrees. So if you remember a unit circle where I guess you could say north is 0 or 360 degrees, east would be 90 degrees, south would be 180 degrees, and west would be 270 degrees. So if you remember that from, basic calculus or high school math, that's what a unit circle is, and that's how we forecast wind direction, okay, in degrees. So here, 17, I need to add a 0 to that, so that would be a wind from 170 degrees, which would be from the south, given my unit circle, 180, so it would be 170, right? So here, I noticed that my wind direction basically all through tomorrow is, let's see, 160, 160, okay? So basically all from the south throughout the morning time. So 160, 160, 115, 170, okay? So basically it's coming from the south, southeast, right? Because here would be 90 degrees, and then here we have 180 degrees. So basically coming from the south, southeast, that means the wind is blowing this way, okay? From the south, southeast. And then as we get into the afternoon, you can see the wind basically stays from a southerly component, but it comes from the south, southwest, and then it flips back to the north as we go into Friday. So here, right, when we get to 18Z, okay, which is 2 o'clock in the afternoon on the East Coast, we see here the wind's coming from 200, 210, 210, okay? So that would be from not the south and not the west, but the southwest. So that means the wind's blowing from the southeast, and then it's changing direction, it's pivoting a little bit, and it's coming from the southwest. So overall, when I'm trying to determine wind direction for the day tomorrow, I'm going to say the wind is coming from a south to southwest, or I could even, make it a little bit fancier, and I can say south, southeast to southwest to north, okay? Because as we go into Friday, we're going to have a northerly component of the wind here. So as I go into Friday, you can see how the wind starts to shift, and now we're, between 3Z and 6C. So between about 11 p.m. East Coast time and 2 a.m. East Coast time, the wind's going to switch, and then it's going to basically come out of the north, all right? So this is kind of an indication of some kind of frontal boundary. It's probably a cold front that's moving through the area, and we'll learn about that more later on in the semester. But here the wind's 32, 34, and then 01. So you add a 0 to that, so that would be 10 degrees. That's how we indicate 10 degrees, so we don't confuse it with 100 degrees, because 100 degrees would be just 10, and this is 01, so that would be 10 degrees. So 10 degrees, 10 degrees, 30 degrees, let's see, 50 degrees, 60 degrees, okay? So it flips from a south, southeast to a southwest to a north, northwest, more north, northeast, and then it flips to an easterly direction. So since I'm dealing with the winds right now, okay, on Friday we're going to go from a north or a northeast to an easterly wind. So by the end of the day, I expect the wind to basically come out of the east, okay? Now, I just used the MOS, but you want to compare the wind direction from both models. So here, the GFS MOS basically says, okay, we're coming from the southerly direction, and then we're going to go calm during the very late hours, so between 2 and about 5 o'clock in the morning, the wind's going to go calm. And then when the wind picks up again, once the sun comes out, the wind's going to come from the south again, and then flip to the south, southwest, and then do the whole north, northeasterly thing, and then it's going to go to the east by the end of the day, going into Saturday, September 12th. All right. Well, that's pretty similar. You'll notice that the times are off just slightly. The NAM thinks this is going to happen a little bit sooner. the GFS thinks it's going to be a little bit delayed, okay? But for the most part, that's what the wind direction can be expected as. I'm not asking you to time these winds. That's a little bit more advanced. I just want you to get used to reading MOS. Now for wind speed, I would just take an average. So, it's very light in the late night, early morning hours, and then it kind of picks up a little bit more. It basically stays for Thursday. It stays right around I always like to go up because wind speed, it's always a method in the forecasting world to whatever winds you see, bump it up by about 2 or 3 miles per hour. So here, very light winds for tomorrow. So I'm just going to say, for tomorrow, 5 to 10 miles per hour. Okay. Nothing special. And then for September the 11th, which would be Friday, as the wind picks up a little bit in the afternoon, right around 11. Let's see, the GFS says the wind speeds, roughly about the same. So what I'm going to do is I'm going to say Friday, the wind speeds, I'm going to bump it up a little bit. I'm going to say 6 to 12 miles per hour. I'm going to, bump it up a little bit just because the numbers on both the GFS MOS and the NAM MOS are both, decently high or higher than they were on Friday. You can see here 11. I want to add a couple degrees to that. Not degrees, I'm sorry, a couple miles per hour to that. So 6 to 12 is fine. Even if it was 7 to 14, nobody dies. Those are minor details. Okay. Now, how do we figure out, right? We did wind, and we figured out the high and low for Thursday. I have to come back to Friday, but I don't want to make this video too long. So let's see, precip amount and precip timing. Okay, this is what everyone typically gets confused on. So we're going to pay attention to the P06 and the P12 group, okay? That means this is the probability of precipitation in 6-hour chunks, okay? And the P12 is the probability of precipitation in 12-hour chunks, okay? So let's see. Here we have Thursday, September 10th, and I'm looking at my clouds here, CLD, and I notice that the sky is broken, and then it basically is overcast throughout the remainder of the day and going into Friday as well. And then, Friday afternoon, we start to clear. And basically, that's the same picture from the GFS MOS. It's going to be cloudy, 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 cloudy. And then late in the day or, overnight into Saturday, we're going to clear out. Okay. So, it's going to be a cloudy day. So, maybe there might be precipitation. So if I look at my precip in 6-hour intervals, by 8 p.m. on Wednesday night, September 9th, there's no precipitation, right? So both the NAM and the GFS both agree on that. By then, meaning to say by this date or in time, so by 8 p.m. on Wednesday, September 9th, there's going to be no precip the hours before that. Now, here, we get to Thursday, September 10th, and here is 6 Zulu, so this is 2 a.m. East Coast time. And I see that the probability of precipitation is 12. Okay, that means 12%. So that means between 0Z and 6Z, there is a 12% chance of getting some type of precipitation, where since we're in September, this would be rain. Now you notice, look at the next 6 hours. The probability of precipitation is 21%. You look at the next 6 hours, it's 26%. Okay. Then you look at the next 6 hours. So we look at Wednesday afternoon between 18Z, which would be 2 p.m., and 0Z, which would be 8 p.m. on Thursday. Here even I get tricked up with this sometimes. I have to double think. So between those two times, the probability of precipitation occurring in a 6-hour interval is 26, and then it increases to 62. And then 6 hours later, it increases to 75. So it looks like if it's going to rain on Wednesday, according to the NAM, and then I want to check what the GFS says too, and the GFS is basically on board. You see that the numbers are different, but the idea is the same. So here we have 33% and then 58%. So this is a good indication to say, all right, between 2 p.m. and 7 p.m., somewhere in that time frame, it looks like we're going to have some type of rain occur, okay? Starting anywhere between 2 p.m. and 8 p.m., okay? And then as we go into 2 a.m. on Friday, look, increases to 64 according to the GFS. It increases to 75 according to the NAM by 2 a.m. on September 11th. So here it's 75. Okay, here it's 64. So basically it paints the same picture. So in layman's terms, I expect the rain to start sometime in the late afternoon on Wednesday and basically run into early Friday morning during like the very early or late night hours of the morning, and basically tapers off throughout the rest of the day. Same thing here, tapers off for the rest of the day, okay? So I know that my timing, okay, is yes, I anticipate rain, and it looks like the best opportunity for rain is going to be, let's say 4 p.m. through, we'll call it 6 a.m. on Friday. Okay, so that's the best timing for precipitation. Okay, and precip on Friday, you can be basically the same thing. All right, you don't have to set yours up like this. You're more than welcome to just describe what's going to happen. That's totally fine too. But if you want some help kind of getting your thoughts down on paper, and if you want to take one parameter at a time, that would be smart, especially since this is brand new to you. So I know it's probably going to rain between that time, and I totally just realized I put this in the wrong column. That's okay. All right. So precip, yes, there is going to be precip. Now, how much, right? How much precip are we going to expect? So this Q group indicates how much quantitative, meaning to say you can measure it, how much measurable precip will there be in 6-hour chunks and in 12-hour chunks. Okay. So let's take a look in 6-hour chunks. So this is 0, 0, 0, 0, 0, okay? And it makes sense because the probability of precipitation is rather low, in the 20s. And then basically the same thing here for the GFS. And you could say here, there's no precip, that is going to be measured, during the day on Thursday, especially up until the mid-late afternoon. Then as we get into the evening time here, you see the number 2. And you also see the number 2, and it's basically the same thing for 12 hours as well. And for 12 hours, okay, 2. So what does that mean? That means it's category 2, which if you watch the MOS video, I highlight the categories, and it's also in the lecture material. I highlight the categories for what means the second column. So I believe, if I remember off the top of my head correctly, the second column indicates rain amounts anywhere between 1/10 of an inch and I believe 1/4 of an inch. Don't quote me on that, but I believe that's what it is. So anyways, between 2 p.m. and 8 p.m. on Thursday, I'm expecting anywhere between 1/10 and 1/4 of an inch of rain to fall. And then it's the same idea. Between 8 p.m. and 2 a.m., according to the GFS, I expect category 3, and the same thing with the NAM, except the NAM is a lot heavier. It's category 5, right? So you have a decision to make. Do you think there's going to be less precipitation, or do you think it's going to be more precipitation? Okay, now I can either cut the difference here, or I can look at some more model guidance, which is what I would typically do in the real world. So I would probably keep it rather low for right now, and then I can increase it later, or I can just split the difference now. It really depends. So in layman's terms, this is what we're going to do. So precip amount, yes, I expect anywhere on Wednesday, I expect anywhere from 1/10 to 1/4 of an inch, not 10 inches, 0.10 inches. There we go. So I expect anywhere between 0.10 inches and 1/4 inch to fall. And then on Friday, it looks like it's going to occur mainly after midnight through about 6 a.m. So I want to say that I'm expecting anywhere between, let's say, a quarter to, I'll be generous and I'll say a half an inch, okay, of rain to fall. All right. Now, this could verify, this could not. I'm being very, I haven't looked at anything. So, I'm kind of just keeping this very, very simple. All right. But that's how you create a forecast via MOS. Okay. So there's a lot of parameters here. I go through them in the previous video on how do you read these. All right. But this is why I say it's very important to understand Zulu time. Okay. Because you need to know where you are and what time you're forecasting for. The biggest question that I always get when I do consulting is, what can I expect? How bad is it going to be? What's the time and what's the amount? So if I'm predicting snow for the Washington, D.C. area, they want to know how much snow, when's it going to start, and when's it going to stop? Those are the main questions that they ask, because that helps plan their operations for how they're going to treat the roadways and such like that. Close schools, what have you, close offices. It really just depends. So that kind of information is very, very useful to decision makers. And that's what meteorology is in the real world, especially when it comes to weather forecasting. So that's why I say, got to know your times. You have to know your times. Okay. So watch that video if you're still confused, or just send me an email and I'll be happy to explain it to you. So I didn't want to make this too long. I know I've kind of rambled on for 20 minutes, but that's just a very basic way on how I create a weather forecast. So if you have any questions, please ask. And if you're a little bit confused, maybe watch this video a couple times and use what I showed you, and then have your location up somewhere else, and then you can click back and forth, pause the video at certain points. You might have to watch these videos a couple times, and that's fine. But practice makes progress.